flying on a CubeSat for that matter. And so they have the ACT, the Advanced Component Technology piece, where if you need like a fancy new piece of an instrument and it needs some development, you can actually get funded to develop a new piece. Oftentimes that'll be in collaboration with universities, say the electrical engineering department at your university might build fancy new metamaterials that you could use to build a polarimeter on a chip. And if that's the case, you'd collaborate with them and go and get an ACT to develop a piece of an instrument. The next step after that is actually building an instrument. So they have this instrument incubator program. And that'll pay for actually building a prototype instrument with the notion that it's potentially an instrument that could fly in space in principle in future. But you're not building a spaceflight instrument, you're building a demonstrator. And then in terms of going to airborne, the next thing is this, yet another acronym, the Airborne Instrument Technology Transition AITT program. So you can take that prototype then and you can add whatever packaging, computers, purge systems, covers and things to take that prototype and make it usable on a plane. So these are the three programs that can take you to an airborne system. And then Lorraine and Vandelay have the HARP CubeSat instrument, and that was through also an Earth Science Technology Office program called INVEST, which is also an acronym. and I have no clue what that one stands for. But anyway, it's a way of funding a technology demonstration to put an instrument on a CubeSat and get it into space. And so HARP CubeSat is a really nice example of what can be done with that, where I think you're only expected to get it up there and demonstrate that it works, right? But it actually worked for 2 years?
It worked 2 years. We would have been successful after 9 months.
Right.
It would have been successful.
And your main problem was Wallops couldn't download the data?
The instrument functioned perfectly. We couldn't always get the data.
Right.
Anything could happen at Wallops. Maintenance, thunderstorms.
And sometimes does, yes.
Yeah.
Okay, so that's building airborne instruments. Any questions? Go ahead.
I think I wonder if you can clarify something. Like, I'm not for me, I don't even think I want to build an instrument because in my head I'm like, well, I'm an engineer. Like,
right.
What if I have like a crazy idea, but I find an engineer that wants to build it? Like, is that something? Like, is that?
Oh, sure.
Okay.
Yeah, because these programs, the Earth Science Technology Office is more technology focused, but it really helps when you're proposing to them if you have a clear scientific objective for that instrument, because then you can tie the instrument development to the science that will come out of it. So you do see scientists collaborating with engineers, and scientists from universities will go to NASA centers or companies to build these things and don't necessarily build them themselves. So yeah, good point. Yeah, and so if you build your own instrument, you can then end up trying to make ice cream in Namibia by an ER2. So that's me with some liquid nitrogen at 6 o'clock in the morning in Namibia, which was actually a really nice place to visit. So suborbital. I've just put this in. Suborbital, the Earth Venture suborbital proposals are very big budgets, at least they seem big budgets to me. It's about $30 million. So if you're doing one of these proposals, you really need to have very clear objectives, have a really good plan for how you're going to make measurements that meet the objectives, and you really need a great project manager. It's not one of those things where if you're at a university, you want to do it on your own. Generally, you probably want to get a NASA project manager to deal with the horrendous details of trying to fly instruments in a foreign country. And I've worked with Mary Klebb at Langley Research Center and Bernie Luna at ESPO, and they're great. It's with that kind of logistical and hundreds of people management problem as a scientist, you just don't want to do it. So that they these groups are a resource, and you can work with them as part of a proposal process to build a proposal. Like the one I'm currently working on is called Activate, and the principal investigator is Armin Sarushian at the University of Arizona, but the project management is out of Langley. Armin's great, he's got a fantastic group of students. He's a very busy guy, and the last thing he wants to do is be involved in all of the nitty-gritty of trying to get everybody paid and flying to Bermuda and all that kind of thing. He doesn't want to be a travel agent. It is a big investment, so you do want to put together a strong team. Hal Maring made a very good point that you don't want to put everybody you know on your team, because ideally some of the people you know won't be conflicted and will be evaluating your proposal and will be knowledgeable about what you're doing. And so you don't want to get rid of everybody who can help your proposal be successful. But you do need to have some experienced people and put together a really strong team for a proposal like this. And in the end, as Jeremy had a really nice thing at the end of his one of his many presentations. What was the bicycle cycling and going off? Oh, the wings, yeah, going off into the distance. Don't be discouraged. These proposals are, they're big bucks. I've been involved in, I think, 10, and 3 of them got funded. And one of them didn't get funded, and then we wrote a white paper, and now it's the directed mission that Hal was talking about, ARC6. So you can have the case that if a program manager sees a proposal that they like that doesn't actually get funded for whatever reason, that can then have a life of its own, and you can sort of go on and write a white paper and potentially have a directed mission where the plane is funded, and then everybody has to write proposals to get the instruments on the plane instead of having to provide your own plane. So I just thought I'd throw a couple of examples up. Names, North Atlantic, and more acronyms. North Atlantic Aerosols Marine Ecosystem Study. This was Mike and Emmanuel's disturbance recovery hypothesis that they wanted to test. So this is looking at how phytoplankton blooms form in the North Atlantic. If you want to know about phytoplankton blooms, don't ask me anything about this figure. Ask Ivona. But
If I want a bottle of wine, then we can talk a very long time about this figure.
So you have clear objectives. It was focused on the phytoplankton bloom, but then as an additional piece, we're also interested in really looking at how the local marine ecosystems were impacting the boundary layer and potentially impacting the clouds. And so the reason this is of interest for climate studies is actually not so much because we believe things like the claw hypothesis or anything like that. It's actually because one of the uncertainties in what the climate forcing today is, we don't actually know where we started from. We don't know what the forcing was back in the pre-industrial very well, and in particular over the open ocean. And so characterizing clean marine environments and the radiative properties of the aerosols in clean marine environments is actually of considerable interest, just to try and understand what it might have been like in the pre-industrial environment. And so that was sort of a big piece of this. And my colleagues at GIS, when I asked them if they wanted to be involved, they're like, nah, it's going to be polluted out there, you're never going to see anything. And that was simply untrue. And we now have the measurements that demonstrate how clean it is, because clouds are great at cleaning the environment. And as all oceanographers and satellite oceanographers know, the North Atlantic has an awful lot of clouds. And so this is just showing the sampling. We were going along 40 west, so going from, basically the ship would go out up and then run up a transect, and some years run down a transect, depending where we were in the bloom life cycle, and make measurements at stations, and then the plane would fly out and provide a large-scale context for what was going on. And I just put this one on. This is not taken from a ship. This is taken from a plane. So this is at 50 meters off the deck in the middle of the North Atlantic, at 44 west, 44 north. So a lot of white caps. But this, the reason I put this is I wanted to just remind myself, an advantage of planes is that they can actually fly under the clouds. So they have a slight advantage over satellites in that sense, in that you can actually make measurements below the clouds and still get some of the ocean context that we wanted to get. On this plane, we had a laser system that could actually work below cloud, and we also could use the diffuse radiation to also look at what was happening with ocean color, at least in providing a large-scale context for what the boat was measuring in much greater detail. Oracles, this was measuring biomass burning over the Southeast Atlantic. So every year, August, September, October, there's burning of the fields to prepare for new crops in Africa, and you have a huge plume goes out over the permanent stratocumulus deck off the Namibian coast. It's the biggest permanent, semi-permanent stratocumulus deck on Earth, and the radiative properties are significantly affected by the biomass burning. So that's an interesting place to do measurements, and had some fairly clear objectives. There really hadn't been good measurements made over the South Atlantic. There were some really nice measurements made during safari over South Africa, but sort of pursuing the smoke downstream really hadn't been done. So we had these nice, in order to compare to models, you really need to have a good sample. So this is when initially we were flying out of Walvis Bay, and then later we were flying out of Sao Tome. But basically there was sort of a regular sampling pattern that was done with the ER2 out of Walvis Bay and with the P3 out of Walvis Bay. It allows you to get an adequate statistical sample that you can compare to models, because the point that was raised about having 10 matchups, it's also the thing with field campaigns where if you make 8 flights, that's really not going to allow you to compare to any models. You really need to have a few more flights, and you need to have a strategy for providing samples that you can intercompare to models. And then activate, again, this is all about cloud interactions with aerosols and aerosol interactions with clouds. I think we should get on with the panel piece of this, but we're going to go to Bermuda a lot, and we started in February 2020. We lasted till March the 10th, 2020, and then we were shut down by the pandemic. So we didn't go to Bermuda very much. We finally went to Bermuda for 2 weeks 2 months ago. And then we were doing things like this. This is a way that you can calculate the large-scale divergence and evaluate whether reanalysis models are actually doing the vertical wind properly. So this is a circle where we drop sons all the way around the circle, and you can use the sons to calculate the vertical motion of the winds. And we did that a couple of times, and then we realized that the reanalysis was doing well enough that we didn't need to do it anymore, because at least in the winter, the forcing from the ocean, when you have a cold air outbreak come down through here, and this is what a cold air outbreak looks like. The forcing of the heating from the ocean is about 1 kilowatt. So small errors in the large-scale winds, who cares? You've got 1 kilowatt of heat coming into your boundary layer. That's driving everything. That's driving the bus. And so the last example, we're going to do a post-launch validation experiment for PACE. We're planning on having 2 planes, one high and one low. The high one's going to be an ER2, and the low one we're currently planning on the Surpass Twin Otter. And the ER2 is going to have Lorraine and Vanderlee's air harps, Specs Airborne, Prism is sort of a UV proxy for OCI, Pinkard is a short-wave infrared proxy for OCI. my instrument, and HSR-L2, which is a very capable high spectral resolution LiDAR that makes measurements at 355, 532, and 1064. Has super high vertical resolution, so you can actually measure the extinction of clouds, and you can also measure in the ocean. They try to get estimates of diffuse attenuation and beam attenuation at 355 and 532 nanometers. And then in Surpass Twin Otter, we're going to have some sizing, some scattering, some absorption, particle counters, measure the precipitation sizes, cloud droplet sizes, and we're going to add in a couple of things to figure out what happens when you humidify the aerosols, because all of these remote sensing instruments are giving you a retrieval for an ambient aerosol. Almost all aerosol measurement packages that go on planes, they dry the heck out of them, so you need to figure out how do I make that in situ measurement representative of the ambient environment that my remote sensing is seeing. And so this is just a couple of gratuitous pictures. This is the Twin Otter. This is the ER2 over the Grand Canyon. This flies where you don't need oxygen. The pilot of this thing is wearing a spacesuit and is flying on the edge of space, as you can see. So they're very different altitudes and speeds, which works out pretty well for validation because your in situ plane can do a nice little spiral. You can have the ER2 come over a couple of times and tie everything together. I just thought I'd throw this in because I like the picture. That's me cycling in Namibia on a bike with big fat tires, and that was a lot of fun. Including you can go down the sand dunes, these really steep sand dunes. You can go down on the bike. The only thing is, don't ever touch the brakes. Okay, so I'm going to do panel now, right?
Whatever you
So
want.
questions for everybody. Go ahead, Bengal.
Sorry for my phone call, it was the coffee thing.
If it's coffee,
Yeah.
it's all good if it's coffee.
I apologize. But in the packs, you did not mention LiDAR. Is there any plan to use
Yeah, the
LiDAR?
HSR-L2 LiDAR.
It is there, right?
Yes,
Yeah.
it is.
Okay,
Yeah.
thank you.
And if I can just say, one thing that I will just say is Kirk is leading the pace backs, Brian is the lead for the atmosphere, I'm the lead for the ocean. And if anybody noticed that something is missing here, like in situ measurements in the ocean, and that's the part that still has to be figured out and how we're gonna do that and everything, so just, I noticed the missing, I just have to say. I mean, Jeremy's giving me a eye, like, I don't have any.
Don't give it to me. I was looking on my watch. I got a text.
Oh,
Evil eye, no, I want ocean there too.
I am.
Is that something that's going to be, a proposal opportunity or not yet?
I will let Jeremy talk about that.
Ace Packs is not something people will propose to. There is a separate validation science team that will be formed that is maybe linked, maybe not linked, depending on how people propose. So, but this specific airborne program is being boxed off to not have it, because it has a very, very clear series of objectives, and there are instruments we know you're not gonna not have AirHarp or not have Specs 1 or Specs Airborne on it, so.
But the plan is for someone to apply for the ocean part and then collaborate with FacePack?
Yeah, so with the validation science, that could happen two different ways. If the PaceBack's budget to maintain the aircraft capabilities is modest, then we can add oceans to it, but we don't know that yet because all of the science investigators with instruments haven't finished the budgets. So that would be directed, or it could be computed. The other way is when the call for the validation science team comes out, there's nothing preventing anybody from proposing to say, I'm going to underfly this, and they could participate in that way through a different one.
Sorry, I've been cut off, I'm gonna stop asking questions.
You've been cut off, why?
There's a question there in the back and then two.
I think my question is quick, what is the plan for the altitude for the ER2 and what is the spatial resolution that you want to get on the airplane?
Altitude for the flights.
The ER2 flies at 20 kilometers. The Twin Otter you don't want to go above 10,000 feet, because then you start feeling unwell the more you go above 10,000 feet.
So when they do the, I guess the aquatic, what is the spatial resolution you get at that?
It varies a lot, actually. So air harp, I think it's tens of meters.
No one, do you remember?
We got at Napier something like 30 to 50 meters.
Okay. So my instrument's about 200 meters. Specs Airborne is also about 200 meters. The LiDAR is 30 meters in the horizontal and 1.5 meters in the vertical. And actually, so they put this vertical resolution in not to do clouds, but to actually make measurements in the ocean, because Chris Hostetler has been working a lot with Mike Berenfeld and Yongchang Hu at Langley. They've been using Calliope and Calypso to do ocean things. And they really wanted something that, rather than just having one bin in the ocean, which is 30 meters, that they could get multiple bins and actually look at the attenuation profiles into the ocean.
And resolve the vertical components that we cannot currently resolve with passive remote sensing. Oh, wait, there was like a question here, and then we go to Riley.
Yeah, Jeremy, just to clarify, what do you mean when you say someone might underfly?
Oh, so that slide for Ace Poll kind of demonstrated what a Pace Packs like campaign might be like. So we're going to fly out of the west coast of the U.S., but the flight track, while it's still not going to be determined and will be based on forecasting. Say if you proposed to, you either were asked to or proposed to be on a ship or have autonomous vehicles or whatever in the same area at the same time, then that would be one way of getting, say, sea truth to complement all of this.
Yeah, and we were expecting that Pace Packs,
Oh, sorry, I'm got it.
and we're expecting that Pace Packs will have more
A drone, maybe.
of this kind of thing.
It's gonna be, this is Ace Bowl.
This is Ace
But
Bowl.
Pace Packs will be much more in the ocean.
Yeah.
Yeah.
So,
Yeah.
yeah.
And over different waters, different type of waters.
As much as we can get it, so I
Yeah.
mean,
Well,
coastal California, go ahead.
I mean, within reason, because
Yeah, yeah.
there may be, say, an event in the water that they decide to do this, but the reason for being for Pace Packs is do everything that has to be done on an aircraft that can't be done if you're not on an aircraft. And if that's, to me, would be the
Yeah.
deciding factor, and then it would be serendipity if the water happened to be changing at that time,
Yeah.
but they might not
But
waste
we
the
do,
cycle.
this is sort of an unfortunate thing. We wanted to try and find aerosols, and there weren't any aerosols over the Pacific, so basically we were looking for fire smoke so that we get a decent aerosol load. But we do know from previous experience that we can do flight lines, say over the Plumes and Blooms line in the channel off Santa Barbara. We know we can go across Monterey Bay and San Francisco Bay, and obviously we can go out through here. This is where you come out of LAX, but the ER2 is like 10 kilometers above the other planes, so you can definitely come out through here. So there's plenty of opportunities to see coastal oceans.
And
We definitely can't fly along the coast though,
But,
just because of the warning areas and the US military and stuff like that.
but there's a lot of stratus out there too. So you can plan these over ocean flights, but you don't see anything but white clouds. You gotta
Yeah.
be careful.
But-
September's not too bad,
Yeah, it's
actually.
not too bad. And one other thing that in California, just because of the topography, no, it's not, but the bathymetry here, you get into the open ocean really fast. So like for difference in the East Coast, I mean like a teeny tiny flight is going to get you like transition from the coastal to open ocean area. And really, I mean, California has lots of stuff. Like really, like you have some river input, you have some maybe real lucky dust deposition and things like that. So. Yeah,
And
for
the
sure.
ER2,
Yeah.
if the way it works out, we pay for flight hours, but in reality, if we're gonna take off we're going to take off and go for 8 hours. So you can go a couple of thousand kilometers. So going up to Oregon or Washington is not a problem. So we have the opportunity to go pretty long distances, either up the coast or even offshore if there are things that people see that they want to do.
Yeah.
But going south is a problem.
Going south is a problem.
Yeah, there's a boat.
Going south, if we go like 50 kilometers offshore, is not so much of a problem. And we can also go to the Gulf as well. Right, we don't have to stay over here. We can go down to the Gulf real easy,
Yeah.
and
Yeah.
that's not a problem.
Mexican airspace, though.
We can go into the U.S. part of the Gulf.
Yeah.
Gulf of California.
No, Gulf. The
He's talking about Gulf of Mexico.
Gulf of
Yeah.
Mexico. Oh.
Yeah.
Yeah, that's in California.
oh yeah, we're going over here.
Yeah, so, going back to that, what Jeremy was saying with the, there's gonna be this call, and then if you happen to find yourself in the area, you kind of like get eaten up, in a sense, join to the Pacebacks project. I don't know how it's gonna work exactly, but it kind of connects to the story of one different type of mission, which is Sabre, which is pretty much where and I think it was similar to what Hal was saying, this is awesome, I want to fund it. There was 3 different projects that were funded, and each of us wanted to do, there was an overlap of each of us who wanted to do something, and each of us wanted to do it somewhere different, and everybody wanted to build, and not everybody, but some people wanted to build, some people wanted aircraft, somebody wanted both an aircraft, and program managers kind of came together, hey guys, we read your proposal, we kind of want to do the same thing, why don't you go, we're going to get you a boat, we're going to get you an aircraft, do the thing together. And it's like you never met these people, and you just now become a directed mission. That's how I started, first time I worked with Ryan, and that was Sabre. So that's a possibility there. So it's not just like program manager picks up one thing. It's you kind of get eaten up by joined together by another project, or joined, in a sense, I don't know, I was trying to make a parallel to your directed project, and this kind of like Sabre kind of came to be that way.
Yeah.
It's also a possibility of doing some kind of experiment mission campaign without ever actually wanted to doing it, but then it happens. Most of the things in my life. Yeah. Questions? Riley, sorry. Riley.
Yes, so I have 2 closely related questions I think you can answer together. So given a successful proposal for a mission that includes building up instrumentation, say something, and it's expensive, say something bad happens, like you lose the instrument, you mentioned something about a pilot running a heater, something like that happens and you don't have enough money to rebuild it or fix the problem, but it's still so close to being completed. What step would you do to fix that? And then secondly, I think a lot of times when people do build instruments, right, they have backup instrument or need extra parts along the way just as they're building things break, because you want to have the ability to swap it out. But if I understand correctly, a lot of proposals you can't really write in when you backups and extras. So you have to think of another strategy to get that, and I'm just curious as to what you do.
Yeah. So if you're building, if you're doing this through the Science Technology Office programs to build instruments, if you fail to get your instrument working, they're not going to give you money. There are people who fail to get their instrument built under IIP, and that's just your problem, and they're not going to help you. If you're doing a big field campaign, you always put in extra money to cover contingencies. But also you always have to design the field campaign such that you have a sufficiently broad suite of measurements that you're robust against the loss of a single instrument. For example, for Activate, we really wanted a microwave radiometer. And there was a group in Colorado, a small company in Colorado that promised that they could build us a microwave radiometer. And we put money into trying to get it, and we never got it, but we designed the measurement package such that we could deal with it even though we lost an instrument. So you have to build resilience into field campaign plans.
well, sometimes that could be a little difficult in the case of like an adventure instrument like how Glimmer was funded. You know, it tried to get funded multiple times, and cost was a huge consideration. You know, keeping it from getting there. In order to kind of get around that, you can use some you know, heritage, you know, elements of the program to kind of help save you money. Those that already have redundancies sort of lying around. That was the case for Glimmer. The pointing element is just geostationary, so you know, needed a certain pointing element, and we used a you know, 30-year-old gimbal that exists, you know, that helps save a bunch of money. There are different ways to do it. There are better ways to do it, but you know, this was a way the mission was able to get funded, leverage what exists, what has been proven to work, and it has backups. So huge cost savings.
That makes me think too, so doing something with like Raytheon, are the prices negotiated beforehand and they have to deliver it, or can they, if they make a mistake along the way and say like, this is going to cost more, people
Yeah.
build their house, and the contractor says it's going to cost more, but.
Right, they try to plan ahead for that and have some reserves in place. Imagine what a
Does
wrench
it ever
COVID
work?
threw into that.
No, it doesn't.
Yeah, I mean, because I mean, it got funded, they weren't planning on having to deal with super long lead times. There was a place that just went out of, you know, a spectrometer that we were gonna use, went out of business. Had to totally redesign. These are all sorts of things that, yeah. That there has been some, you know, back and forth about at least getting some of those COVID costs sort of, you know, supplemented, but they have to keep a close track on all that every step of the way.
Well, we always buy spare parts, more parts than we're gonna use. Oh, it's
Yeah.
plenty. Sometimes it's the same price to buy 3 or something than to buy 1 of it.
But in the proposal though, you can't say spare parts, right?
No, you
Oh, you-
just say that you're gonna buy detectors, you're gonna cost this much.
Yeah, and you buy 3.
You buy 3. That's why Heart 2 could be contributed to the project, because these were spare parts from Heart CubeSat.
Okay.
So most of our science is pretty much like, you know, what do you call it, trash diving, like, you know, you get the gimbal that somebody threw away leftovers.
Dumpster diving?
Dumpster diving. See, it doesn't get translated easily, but I mean, like, even if you're not building missions, I mean, I know at least on the oceanography side, a lot of you go to field, you know, and when you're packing for field and stuff, you're always packing for conditions. There's so much, you always like, you know, you always buy a little bit extra. I mean, and then you just have to figure out a way how to write that extra into your proposal without really lying, but also buying extra. You know, I really was smart people.
Yeah, you can always buy extra parts. That's expected actually, because oftentimes you'll want to
Don't say it's extra
upstream.
parts, it's the set.
Supplies.
For Esto, they're okay with extra
Yeah.
parts actually.
I was gonna say, PacePass is a little bit different, but all of the other examples of I think it was the Adventures ones that you showed were multi-year and multi-platform. Is that really typical for the NASA campaigns?
No,
No.
depends which
Oh, I'm
ones.
sorry, multi-foot, not multi-year.
EV suborbitals, there's some that are just 1 year.
No, I don't think there's ever been.
FireX?
That wasn't EV.
Yeah, but.
FireX was
Like
directed.
gas X, so.
Okay.
But there's,
Gas-
there's
yeah, but
plenty
those were- yeah,
of
those were
field
directed,
experiments
yes.
that just 1 year.
It depends.
Pardon me?
Okay, I'm just more familiar with the NSF ones.
Yeah.
Multi-platforms, you typically don't get multiple years at a time.
Yeah, so the EV funding period is usually 5 years.
Okay.
But if you look at how much planes and boats cost, usually the data acquisition piece of it is pretty much maxes out at 3 years. So like usually it ends up a year prep, 3 years of measurements, and a year of analysis and writing lots of papers. So you can try and propose to get another 5 years. I think the 3 I've been involved in were multi-platform ones. And I think that's a huge selling point when you're going to NASA. Like names, for example, the C-130 that we were flying on was nicknamed 50 Shades of Grey because you had to be a masochist to go on it because it vibrated so much. And it was just a horrible thing. But it lasted for 3 of the campaigns. And then on the 4th, we had an engine failure, and the plane couldn't go. And that if we hadn't had a boat that was actually going to do the last part of the plankton bloom cycle, it would have been a disaster. But the boat could still go, so it was okay. So yeah, I think having multiple platforms is hugely beneficial. And you have to, and since we're talking about proposals and, you know, seeing what you can and can't do, obviously names, we were up in St. John in Newfoundland, and oracles, we were in Namibia, and then the Namibians didn't like us anymore, so we went to Sao Tome and Principe. And then activators, just a couple of planes flying out of Langley and then going to Bermuda for 2 weeks. So you can see that there's a transition in the selection of proposals in terms of the risk profile. Right, activate, low risk, you're flying out of a NASA center. Whatever happens, you can definitely repair it. The others, much higher risk. So, you know, you have to bear that in mind also when you're proposing. Right now, it seems like headquarters has a pretty low tolerance for foreign country risks. So, campaigns that are in the US, obviously Alaska, if you can base out of an Air Force base in Alaska, that would work also. But yeah, it seemed like they were really risk averse in the last round, because all of the ones I was involved with that had anything to do with a foreign country, no.
But it cycles.
Yeah, it does.
Cycles.
10 years from now, when you're writing the proposals, they may really like the international.
Yeah, and so it was good that we had the program managers, right? Because what you call a program manager. It's like, can I do something out of Thule in Greenland? Yeah. It's like, okay, good.
One thing that can easily change their mind, and this is from the ship's perspective, is the price. So for us, when we were doing exports, which is a directed mission, I think that kind of falls into that group. Originally we planned to sail out of the U.S. with U.S. vessels into North Atlantic, but then the price tag and how awesome those ships are going from British side changed the mind completely. I mean, we cut down the price for like 50%, and if that means bringing 70 scientists across the ocean in the middle of pandemic and putting them in a hotel for 14 days with all bells and whistles, that was still cheaper than using U.S. vessels. So that changed their mind. So just kind of
Interesting.
yeah, I know how to shop. You need ships, I can get ships.
Have a lovely lunch break. See you.